Let's talk about exponents. This right here, this is called a power. A power has two different pieces to it. This first piece right here is called the base. It's the base because it is the big number that holds up the small one. It's the big number on the bottom. This number right up here, it's the exponent. It is the smaller number that the base holds up. Between the two of them, they make a power. I have some examples right here of some powers. This right here says 3 to the 5th. That's how we would read that out loud. And what that means 3 multiplied times itself 5 times. 4 squared, or 4 to the 2nd power. That means 4 times itself 2 times. 10 cubed means 10 times itself 3 times. You can see that these numbers get really big pretty fast when you're dealing with exponents. 5. If I ask you what the exponent on this 5 is, you may say there isn't one. But there is. We just don't write it. It's implied. When you have a number and there's no exponent on it, the implied exponent is 1. This is 5 to the 1st power, which means 5 times itself 1 time, which is just 5. So any number out there without an exponent really does have an exponent of 1. The one thing I need you to know today is that when you are entering exponents into Brain Honey, which is where you'll be entering your assignments, you're going to need to be careful and know some special tricks for entering exponents into your assignment. You have sometimes, and you don't have that option right now, but you eventually will have the option of using an equation editor to be able to enter an exponent, but right now you don't. And so right now you need to be able to enter an exponent like this. This right here looks a little funny, but what it is saying is 3 to the 5th power. This little symbol right here, you will find it on your keyboard. Take a look at the number 6 and look at the symbol right above the number 6. It looks like this. It looks like an upside down V, and we call it a caret. Not sure why it's called a caret, but it is. That symbol is called a caret, and it's a way to enter exponents with just your keyboard. So if I wanted to enter 3 to the 5th power, I would enter it like that. I would enter 3 caret 5. If you're dealing with like a graphing calculator, like a TI, if you have one or if you've played with a friends, this is also how you enter exponents on the TI and some other scientific calculators that you use this caret key. And so this would be how you enter 3 to the 5th. This says 4 to the 2nd. They are the same. Both of these are two different ways of writing 4 to the 2nd. So if you are doing a problem and you need to enter the answer 2 to the 3rd power, you're going to enter it using your keyboard like this. You're going to enter the 2, you're going to enter the caret, and then you're going to enter the 3. And that'll be how you get 2 to the 3rd power. If you end up and you're doing problems and you're not sure how to enter notation, please give me a call or shoot me an email or meet me in office hours, because as important it is to be able to understand the math, you also need to be able to know how to enter it correctly too. And so I need to make sure you've got that. Okay, let's move down on here to some examples of using powers and exponents. This is 3 to the 4th times 3. There is an exponent on this 3, and it's a 1, whether we write it there or not. Let me write out how this problem looks like. 3 to the 4th right here, that's the same as 3 times 3 times 3 times 3 times 3 to the 1st. That's the same as just 1 3. How many do I have here? 5 of them. So this is 3 to the 5th power. Let's take a look at this one right here. 2 to the squared times 2 to the 6th. That's the same as writing 2 times 2. And 2 to the 6th power is the same as writing 2 times itself 6 times. If you can see here, I have 8 2's, so this is equivalent to writing 2 to the 8th power. You might have noticed that there's a shortcut here. Take a look at these answers, and if you can see if there's a way to get them without writing out all of these, this whole long multiplication problem. When you want to multiply powers, if they have the same base, you can just add their exponents. You can see on this one, there's an exponent of 2 and 6. So if I'm multiplying these powers, I can get 2 to the 8th power. Same thing up here. If I had just added the exponents, I would have gotten 3 to the 5th power. So let's use that shortcut for these bottom two problems. Here we've got 10, which is 10 to the 1st, times 10 to the 3rd. If we just add those exponents, we get 10 to the 4th. Right here we've got 6 to the 8th times 6 to the 2nd. Adding those exponents gives us 6 to the 10th. Now the one thing you need to know that is very, very important is this trick of adding the exponents only works when they have the same base. Both of these had a base of 2, so it worked. If I had a problem like this, 3 to the 4th times 5 to the 10th, I cannot use that trick because they do not have the same base. In fact, it doesn't even work. This is actually as simplified as it can get. So be sure that you only use this when the bases are the same.